All right, so one of the challenges that happens when you're doing multitemporal remote sensing analysis of using classified images like we have here is that you can have cloud features or other issues where you want to standardize features in your data set across multiple time periods, time steps. So I've got some data here. There are two classified Landsat 5 images from a part of the eastern Brazilian Amazon. You kind of see it's on the edge here near the city of Marabá is located here. And I have an image here classified from 1988, and there's one from 1996, and there is one from 2000. And each of them have some white pixels here. These are clouds. And so if I want to make multi-temporal kind of area calculations, for example, I need to remove these areas from my calculation. And so what I'm going to show you today is how to standardize clouds or other features, for example, water. So another example here would be this is an area where uh, water bodies shift quite a bit, and so maybe you want to standardize water so that those there's not as much change over time in your data set because you want water pixels to stay the same. At any rate, we're going to make extensive use of two tools here. The first one is the con tool, the conditional tool, and the second would be Raster Calculator. So what we're going to do is we're going to access our geoprocessing tools. In this case, we're going to search for the tool con. Here's con. You can use either of these, con spatial analysis or the image analyst. You do have to have a license for these, but many people do. So our first step is going to be to input each of our rasters and go through this con tool one by one. Our conditional raster is going to be our input data set for 1988. Our clause here is going to be if the value in this image is equal to category 5, which is our clouds. If it's equal to 5, we are going to make it equal to 5. And otherwise, we're going to make this raster equal to 0. And we're going to call this, we're going to output this as, we got to be careful with our file names. We're going to call these clouds 1988. And then you just run it. Con will run fairly quickly. What it's going to do is it's going to replace all places that have a value of something different than 5 with a value of 0. So we're going to have a raster here where our clouds remain equal to 5 and everything else is equal to 0. It should show up in a sec. And indeed, that's what we have. We have our clouds are equal to 5 and everything else is equal to 0. So we're just going to go through and do this multiple times. We're going to do it for each of our images. So now I'll do it for 1990. The cool thing here is all I have to do, everything remains filled out. All I have to do is change my output name and input name. This is an advantage of ArcGIS Pro over ArcGIS Desktop. You have, when you run a tool, it'll just stay up there. You could do the same thing in ArcGIS Desktop, ArcMap, by using the results window. But this is kind of even more convenient. All right, there's 1990 done, and now we'll do the 2000 image. Now we have all three of these, we need to move back to our tools and find Raster Calculator to combine each of these together into a single map of clouds. So what we're going to do is search for Raster Calculator. Here it is. And we're just going to add these three rasters together. We're going to add clouds to clouds to clouds. Now, what this is going to do is it's going to combine them all. If there's a pixel that's clouds in no image, then it will have a value of 0, because 0 plus 0 plus 0 equals 0. If there's a pixels that are clouds in one image, it will have a value of 5. If there's pixels that are clouds in two images, that pixel will have a value of 10. And if it's in 3, it will have a value of 15. So we're going to run through this and see what our output looks like. We're just going to call it simply clouds, because it's all the clouds. Chances are our highest value is going to be no more than 10 here, because we had clouds down here and over here, and then some spread across this area. But we might get lucky in this case and have only the value 5. No, I was wrong. We have values 0, places with no clouds, places with the value of 5, clouds in 1 year, places with the value of 10, clouds in 2 years, and 15, clouds in 3 years. If we want to see this more clearly, we can change the symbology real quick to maybe more of a stretched classification. And we can have our background value of 0 not included. I'm changing it to a different color scheme so there's more variation in the colors of the clouds that we have in this image. Anyway, we could do it via a discrete and then change the color scheme there to probably work better. Sorry, unique values. There we go. So in this case, we might put 0 as no color at all, 5. 5 may be very light red, 10 may be a darker color red, and 15 is very red. We'll take it a moment to draw. Like so. Now there aren't very many 15s. So anyway, now we have a problem, because if we stick these data values in, our classifications here in our data are going to, we're going to have 3 categories for clouds, and we're not really interested in that. We just want clouds to all be one. So, and we want them to be standardized. So we're going to go back to our geoprocessing toolbox here, and we're going to use the Reclassify tool to make all cloud values 5 again. Again, you can use 3D Analyst or Spatial Analyst. They're the same tool, but you do have to have a license for them. So in this case, I'm going to take my overall clouds map, and I'm going to reclassify it such that if the value is 0, it's going to remain 0. If the value is 5, it's going to remain 5. If the value is 10, it's going to be 5. And if the value is 15, it's going to be 5. Now this is because if a value is above 0 in this data set, it has a cloud during at least one of these years. And so we want all clouds to have the same value. So we're going to call this one clouds final, for example. Click run. And what we should end up with is another, anything that's not clouds is 0, and anything that was clouds during any of these years has a value of 5. Let's see what we come up with. And that's what we have. So any of these blue pixels here are clouds during one of those years, and any of these red pixels were not. Okay, so now we can use the con tool again to copy these cloud pixels into each of our images. Now, when you do this, you want to be really careful because you don't want to overwrite your original data. If you do so, then you will never be able to use, say, one of these individually to see what's going on at a given time as a unitary observation instead of a multi-temporal time series. So what we want to do is we're going to input our clouds final raster here. And what we want to do is say if the value is equal to 5, then we want to put the value of clouds final in here. So we're just going to take the value 5 and keep it 5. But if the value is not 5, then we're going to make it equal to 1988. And we're going to want to name this 19 cloud. I'm going to call it cloud std standardized, right? 1988. I'm going to run it. And so what con is doing here is any place that's equal to 5, it's going to keep as 5 in the output raster. But any place that is not equal to 5, it's going to take the values from 1988 and copy them into the new raster cloud std 1988. And so now we have a 1988 image. Let me see here real quick. I'm going to go to symbology, and we are going to we import it from another layer. And we're going to just replicate our original thing here. So one's forest, we're going to change the color, make it green. 2, we're going to make gray like our original one. 3, we're going to make some kind of magenta color over here, just to approximate our original land cover map. 4 is going to be this bluish color, and then 5 will make white for clouds. So what you'll notice here, once the view draws again, is that we now have 1988 land cover, classified land cover, but clouds exist everywhere there were clouds during any of the 3 years. We've standardized cloud cover. So again, we can move on to the next year in ArcGIS Pro just by changing the false raster and then our output name. So what I'm doing here, all I've done is I'm keeping, if it's a number 5 in clouds final, it will be a number 5 in the output. But I've changed, if it is not a number 5 in clouds final, it is now going to copy the cells from 1990 into the new raster, and I've named it to reflect that. And then you just do the same with your third one, standardizing clouds across all of your time series. That's all there is to it. So we used the con tool, we used reclassify, we used Raster Calculator, and then we used reclassify, and then con again. And that's all there is to standardizing features across multi-temporal Landsat series, for example.